Hi everyone, thanks for joining in early. We'll get started at right at 8 o'clock, so there are still a couple of minutes to go. Hi, can you guys hear me? Just want to confirm. All right, so the audio is working. So we'll just get started in a couple of minutes right at the top of the hour. Thank you for joining in early. Hi everyone, thanks for joining in. We'll get started in about a minute. So while we're waiting, why don't you use the chat window and tell us where you guys have logged in from today? It'll help us get a better sense of our audience. Oh, there's a person from Belgium as well. That's perfect. Oh, there's a good diversity in the crowd today. Gurgaon, Chennai, Bangalore, Hyderabad, Pune as well. Perfect. Kolkata, Hyderabad. It's a great diversity. I'm glad all of you guys are on the call today. And we'll just get started in about 30 seconds from now. All right, let's get started, everyone. Hi, everyone, and welcome to today's webinar on building a recommendation engine. My name is Pranav Dar, and I'm the senior editor for Analytics Vidhya, and I'll be the moderator for today's webinar. I'm delighted to be joined by Rajesh Jayapal and Binu Midhun from IBM, who are presenters today. Before we kick things off and I hand it over to them, I just wanted to quickly cover a couple of administrative items. First, of course, we are recording the webinar, and the recording will be available and shared with you the next 2 or 3 days. If you face any technical issues, such as the audio going out, please log out and log back in. That will usually solve the problem. In case that does not work, we are also streaming this webinar live on Analytics Vidya's Facebook account, the link which I've just posted in the chat window, and you can just log in there. All right, on to our presenters today. Rajesh K. Jayapal is an architect, developer advocate, and startup mentor at IBM India. His technology focus is on AI and especially on distributed environment. In his 22 years working in the technology sector, 22 years, that's brilliant. He's led various product development projects and open source projects. Binu Midhun is a data scientist and has overall 10 years of experience in the IT industry. She's worked on complex computational modules for retail and financial institutions and is experienced in AI technology. So, without any further ado, I'll hand over the stage now to our presenters. So, first, Rajesh, over to you.
Thank you, Pranav, and good morning, good afternoon, and good evening to everyone. It's really glad to see your interest logging in from Belgium, Nigeria, and then different parts of India. So today's talk is about building a recommendation engine. IBM and Analytics Vidhya, we worked together and we made an online practice problem available, and it's been running for about 5 months now. And today's discussion, we want to take you through the problem statement that is given, and also want to give you the quick background about the recommendation engine, and helping you to take the next step in terms of building a recommendation engine for the given data set. And I'm sure this session, whatever we are going to discuss in another 45 minutes or so, will help you to take the next step. And most of you might be already familiar with the concepts around recommendation engine, the flow of things, how that can be approached. And most of you might be quite new to this, catering both the requirement, right? We taking the next steps in terms of giving you the understanding about the recommendation engine and also a baseline program. So now, if you are not familiar or hearing it for the first time about this practice problem, you can search for analytics. You can get into the analytics Vidhya page and then search for the contest IBM recommendation engine. Or now we have provided the short URL ibm.biz/build-re. That will take you to the practice problem that has the details. And from IBM side, we encourage you to use the IBM cloud. If you are again new to the IBM cloud and have not used it, probably you can register for it. We have given the short URL, and we encourage you to use this URL, IBM Cloud AV. And IBM, especially keeping the developers in mind, we provide sample codes or solution scenarios being implemented using various open source components and other services that are available in IBM Cloud. And it's a good collection, not only for the recommendation engine or AI, but it has the content for all the technologies, be it Kubernetes, be it IoT, like be it anything specific like blockchain, right? So that's a good place to start with if you want to really get explore with the technology. So that is developer.ibm.com/patents. And coming back to the our practice problem to build the recommendation engine from the IBM Cloud perspective, we have two key components. Now one is the Watson Studio, and another one is Watson Machine Learning. And Watson Studio, it's basically the development environment which helps you to kind of build a machine learning model. And I'll talk about that in detail later. And Watson Machine Learning helps you to expose the model as an API endpoint. So these are the two key components you can kind of look to explore. Yeah, so coming back to the recommendation engine, this is not something no, this is something very familiar to us. We keep kind of being recommended at various like stages, whether we log into the online the retail portal, right, or whether we want to kind of discuss about choosing something, right, with someone based on the various aspects that we have been recommended on the things, right? So recommendation system, right, on that aspect is broadly classified into three types. Okay, one is popularity based. This is little straightforward, right? Anyone can recommend based on the popularity. Like whether doing an engineering or commerce is good. Some people will say that, okay, go ahead and do the engineering, right? Few will say that, okay, commerce could be a choice, right? Or it could be a other way around, right? So there is a kind of a popularity, kind of ranking involved, right? So popularity based. And the other one is, the feature specific, right? So if it is a product, the product specific to the product features, people will kind of analyze and then kind of try to kind of list the most the popular one, or the one which can be recommended, right? So that comes under the category of content based. And there are few kind of approaches and methodologies available to kind of take a decision on the content based one. And the most popular one is the collaborative filters, right? I'm sure who are all familiar with recommendation engine might have used CF quite extensively, right? And the key difference here is basically collaborative filter makes use of the past data, the historical data, unlike the content based, which specifically looks into the product features, right? So collaborative filter certainly kind of deals with the past data. And within the collaborative filtering method, there is a memory based method and a model based method. Okay, so the memory based method is basically the user to item relationship, right? So like based on the user's preference, right? So what can be recommended? Okay, so there is not a deep level of machine learning kind of an approach involved, and probably that's the reason it is called as a memory based model or a method, right? And as we know, yeah, machine learning is certainly an optimization problem, right? And that is why it is becoming very popular now. Especially the 200 years old algorithm is being explored extensively now. It's mainly because we are able to compute very quickly. We have the high compute capability environment we have, right? So keeping that in mind, right, the collaborative filter, whatever we do with the user and item based things are all like we cannot really categorize that as a machine learning, but we do have, considering the complexity in the data that we deal with, right? So we have to get into the machine learning model, basically the vector decomposition, and the matrix factorization. That is what is listed over here as a SVD and the NMF. We will quickly see, what is the kind of optimization that happens under that. And before we get into that, we will see the memory-based approach. So this is the quick gist of the data set that we have provided for this online practice problem. And it's a straightforward data where customer ID and their buying, the products, the items that have been purchased by them. Okay, and we have the other data as well in terms of the number of quantity that is being bought, right, and the country, the region specific information. This is something which you may consider or you may not. Okay, that's completely up to you to decide in what way you will kind of approach this data set. But from our discussion per se today, we will take reference to the customer and the product, right? And so recommendation engine, as we kind of like the collaborative filter depends on the past data. It especially builds a matrix, okay, based on the past behavior. And the kind of data it depends on is there are some explicit way we give the feedback, right? So the ratings. Okay, so this again goes as an input to build that the ranking matrix, basically the the user and the item relationship matrix, right? But there are again some implicit way. People will spend some time on top of a particular image, right, or on a particular page, right? So this implicit data also is considered, and both this data plays a role in terms of kind of defining the rank for the user and the product items. And see, when we say user based, right, it's pretty kind of understandable if a scenario is like this, right? It's pretty straightforward. Okay, the relationship is it's quite open, and we can easily say that like the movie preference by that particular user C would be rating 3. Okay, but when it comes to this particular the rank matrix, right, again we try to get into some sort of similarity approach, right? Probably the for user 1, right, have a close similarity with the user C. So on that aspect, we can kind of provide the ranking, right? So the correlation plays a major role over here. And there are various different approaches. Euclidean distance, it's again a common one which I have not listed over here, also plays a role in kind of identifying the relationship. Okay, and Pearson correlation and cosine similarity is something very frequently used, right? And anything which closer, right, and positive correlation, right, that is represented as +1, and there is no correlation at all, it's indicated with 0. So that is how the Pearson correlation gives us the information in terms of in what way the items purchased by the user, right, is closely related with the items purchased by the another user, right? So this is something I would say as a kind of a first step in understanding the behavior, the nature of the data set that is given to us. So scatter plot is something which we can consider using to plot it and identify, right? And cosine similarity works similarity between two vectors, and it's a very basic 10th standard high school mathematics in terms of the vector dot product. And it basically considers the magnitude of the association. So that is the the common feature between the Pearson correlation and cosine similarity. And right, so how close it is, right, in terms of the magnitude. Okay, right, so in case no, like if you do not want to kind of no, get into the magnitude aspect, okay, then probably you can consider using the cosine similarity, right? And Pearson is something which, where if you want to really consider how closeness from the magnitude perspective, then you can consider using the Pearson, right? And the cosine similarity is useful for the instances when you do not want to consider the magnitude. Now you have to think from the aspect of the data set that is given, whether Pearson will work better or no, the cosine similarity, right? So that's something, like which you have to plot it and observe, and then you kind of take a call, right? In whether Pearson will help or cosine similarity is going to help. And of course, from the machine learning, the data scientist perspective, they tend to go with all the options available and then pick the best one, right? So that is something probably that can be considered when we would like to understand the similarities, right? Yeah, so this is the nature of the data points, right? So if I ask you what is the correlation you could observe, it's quite difficult. I don't think we can make out, right? So this is no, like we can say that there is no association between the items over here, right? But practical scenario within this scatter plot also, you will see some sort of correlation for a sample of the data set, right? So that is something which you may have to consider, and you will understand only when you plot it. So when you do the plot of the whole data set that is given, and then probably you can check for the subset of the data where you see some level of either a positive correlation or a negative correlation. In this data set, I cannot really make out a positive correlation. Otherwise, if you see a sample subset of the data points, you may see a trend of there is a correlation that happens in that particular sample. So it is up to us to kind of know, like, but that gives us a little, like we have to be a little cautious in terms of that doesn't mean that the whole data set is completely like like each items are related, right? So that we need to be a little cautious. Okay, so this kind of a data plot looks scattered, but certainly like when x increases, y also increases. Okay, so it may not be an absolute one way of positive correlation, but the relation will be definitely in between 0 to 1. Okay, so this is for our understanding. And and in reality, the user behavior like we may not get the complete information. The data will be certainly a sparse one. And so how to deal with this sparse data, right? So that is where like no the optimization approach will help, right? So if you get into a scenario where the data is not complete, right? And if you are taking the making use of the collaborative filtering approach, right? We may have to extend ourselves to consider using the optimization approach. Okay, so like as I mentioned, either the vector decomposition or the matrix factorization. I will quickly take you through about the the matrix factorization. So matrix factorization is splitting the ranking matrix, something which is very familiar for us, right? So assume that this is the like the end target for us. Okay, and right, so the items and the user matrix. Okay, right, so how to kind of split this up, right? And what we mean by optimization over here. Okay, that's something we will quickly understand, right? So we are splitting this rank matrix into like two different matrices. One is an user factor, another one is an item factor. And so you can make out the user one like ranking for movie one is 3, and that is splitted into considering couple of other features. For example, the like the movie data set, right? Comedy, the user one prefers the comedy, and no, that gets the rating 1. And so similarly, from the movie perspective, comedy gets 3. So if you do the multiplication, you will see 1 into 3 and 0 into 1, you'll get 3, right? So this is how basically, like we factorize the rank matrix. But the what is optimization part over here, right? We have to start with some value. Okay, so as I mentioned, machine learning is an optimization problem. And so the it is all about fitting like into a particular algorithm, right? And so finding the coefficient for the algorithm. You take a simple example of a linear equation. Okay, y is equal to, say, some coefficient b0 plus b1 into x, right? So now the machine learning problem, given that x, right, we are trying to find y. And so both y and x is given in our training data set, and we are trying to find the coefficients b0 and b1, right? So we will start with some value of the coefficients, and then we will see whether the x and y, as per the given training set, it is coming close, right? And then we will try to kind of reduce that, or minimize that error, right? And try to get an optimal value of b0 and b1. Okay, this is from the linear fitment perspective. Okay, similarly here, the recommendation engine, the optimization involved in the rank matrix is like, as we have seen, like we are factoring the matrix, and our target is get this matrix, right? And so we have to start somewhere. So we start with this value, and then we see like whether it is coming close, right? So we keep on kind of like iterate on this, and then find out an optimal value which comes closer. Okay, so the error that is basically kind of used is basically the root mean square error value, basically getting the from the actual to the one what we have, the target to the actual what we have got, right? And so recommendation, this is the common thing for any linear and logistic regression uses the log loss approach, right? And so basically this is an optimization approach which recommendation engine uses to get the rank matrix filled out, right? So once we get this, right, and then basically using the correlation factor, right, and also by creating a rank for the user and the item that we have like that is available for us, right? We will be able to get the the top things recommended. That's something we will see little deeper in the next with reference to a particular implementation. Okay, but I just want to give you this the approach, a basic simple approach, right? Like given a data set, right, you like you have the option of getting into the collaborative filtering, and then kind of use the correlation factors, right? Whether it is a Pearson or if you feel Euclidean distance also can be used, right? You can kind of try that out as well. Okay, and then kind of you can experiment with the optimization approaches like the matrix factorization. Okay, so it's a very quick background, but we will see little more deeper from the implementation perspective with which Binu will be covering, right? I want to kind of take you through from the implementation perspective. Okay, see, implementation perspective, certainly like the machine learning environment, like our preference is a Python code, and we always look for an environment which will kind of help us to effectively build the model. Okay, as I mentioned, the machine learning no, it's kind of it's becoming familiar now. It's mainly because of the compute environment we have, right? So on that aspect, right, from IBM cloud perspective, we have a component called Watson Studio. Okay, so what you see in the screen now, if you log into the IBM cloud, you can get into the catalog page and search for Watson Studio. And so the consumption of the service is just kind of click on that. And this is a development environment which has the support of various processing unit, be it a CPU, a GPU, and the cluster based Apache Spark environment. And also these days we have a distributed deep learning environment, like where you can kind of take the approaches of training the model in a DDL manner, right? So this provides the compute environment, and that is one thing. So that is while selecting the service, you will while trying to consume the service from the cloud, you will kind of try to understand what sort of computer environment that is available and what is that computer environment you can go with. And now this is absolutely free for you for the basic computer environment. And you, for this particular practice problem that is given, what you have tested, you can comfortably use the free plan that is available. Okay, so there is no kind of financial commitment over here. So take the Watson Studio and then kind of go with the infrastructure what you have. And then once you kind of open the Watson Studio environment, this is the kind of a thing you will have where you can kind of create the Python notebooks. And the various environments, as you could see over here, right? Like here in this case, I have taken a GPU environment, but you have the option of selecting, as I mentioned, the distributed, the Apache Spark environment, and the various Python 3.5, 3.6, right? So the environment something which you feel you're comfortable and required for this particular model training requirement, you can pick and choose. And then it's all about rest of the Python notebook what we use regularly, right? So from the online practice problem perspective, right, we encourage you to kind of use the Watson Studio environment, where you can kind of either move it from your the model which is already developed, like if it is available in the external GitHub repository or anywhere, you can move it over here, or you can kind of develop it from the scratch over here, right? So this is something which we strongly recommend. And from the online practice problem perspective, the evaluation technique what we have used is FN score. And we will quickly show the the recommended item, how it is kind of submitted and gets evaluated. Binu will show that when she takes us through the implementation part, right? So we have based on the FN score, we are evaluating your model. And like some of the basic evaluation like we are doing, because you are asked to submit an CSV file which has the customer ID and the items that you have predicted or recommended based on the data set given. And then we check for few uniqueness of the customer ID, and any blank things are kind of getting rejected, right? Some of the other basic validation that is required that we have put in place. Okay, so you are at the end, you are asked to kind of submit an CSV file only with the customer ID and the recommended items. Okay, so we have provided 50% of the data set for your public, the leaderboard. So as soon as you submit, you will see the performance of your model. And then during the evaluation phase, which happens the end of this month, we will use the private data set, what we have, and then kind of we will evaluate, right? So with this, I would like to give the message is explore the online practice problem with the given data set, right? And this is a very like the basic steps we have given, right? The collaboration, the collaborative filtering, and the cosine similarities, right? And then the optimization based matrix factorization based, right? And there are quite a few things, of course, you have to consider, which Binu will take us through. And the data the processing that is like required, and the ranking, right? How that can be done. Why? Because a data set of this nature, there is no closed boundary. If it is a movie related thing, like the ranking, there is a closed boundary. But here it's continuous, right? So how a data set of this particular nature, right, we can consider building the rank, which something Binu will take us through. Binu, probably you can share the screen now. And so we will try to understand from the implementation perspective. And this you can consider it as a base program. And we really encourage every one of you to kind of, take this as a base program and submit, and then start working on it, like to kind of improve it, based on the understanding and the skills, what you have, right? So we love to see the contribution from your side, and then I hand over to Binu to kind of take us through the implementation part. Binu, over.
Thank you, Rajesh. So hi, everyone. There's a lot of excitement for recommendation system. I'm very happy for that. So we all do shopping, right? And shopping is a necessity of every human being. And when we do that, it's either the product we like or it's like somebody recommended to us. So whenever we're buying some products, we have to remember that there is some kind of recommended system that is working behind that. So now you know that this is very important. I will see how we go through this. But before that, I see some questions on the chat asking about the registration link. I have posted that. And when you do the registration, you will be getting a light plan, which is a free plan, free plan, and you don't have to pay. You will be getting some 50 to 60 services, and you can upgrade, you can pay as you use it. So that is about the IBM cloud services. So let me just start the registrations recommendation system. Right. So let's talk about the implementation part. So Rajesh has already introduced that when we do a recommendation system for movies, it's comparatively much more easier because we have the ratings from the user. So the user would rate the movie from 1 star to 5 stars, and we have some sort of basis from the user to how to recommend to the other people. So based on the similarities of what movies they watch, we can easily recommend movies. But when we come to product purchases, it is not simple because it is a continuous values, and we need to form some kind of ranking is required for this. So today we will see, we have put up a challenge in Analytics Vidhya, as you all know now, and we will see how we can implement it using the technologies and using the algorithms that Rajesh has introduced to you guys. So the first step, in this would be to import the modules. I will take you through one by one, but just to give you a pseudocode kind of a field. So we are going to import some important libraries like pandas, numpy. We're also going to use something called Tury Create, right? So Tury Create is a library for performing model selection and evaluation. We will also be using sklearn. As we all know, whenever we have doing some machine learning algorithm, there's always that data split into train and test set. So we will be using sklearn for that, right? And then the next step would be, as you see, it will be loading the data. As you all know, we in IBM Cloud, we have something called Cloud Object Storage, and that will be your storage. And we will see how we can browse. It's very easy. You can just browse some files from your local system and upload it to your Cloud Object Storage. The third step is of the data preparation. So, eventually we have to get to a stage where we have some kind of a rating or a ranking, right? So the first step to that will be that we create a data with a user, item, and a target field. I will come to this target field, but just to begin, purchase count. Purchase count is something very easy that, we can use as to compare and see what is the purchase count of this item. So that can be a basis for our algorithm. So the target field in the first case will be a purchase count, right? And the second thing is create a dummy. So first is a purchase count, second is a dummy. If a customer buys an item, then the purchase dummy will be marked as 1. Otherwise 0. So one thing that we all can have a doubt is why can't we normalize the purchase count, say by the user? Why would we do that? So we cannot do that because customers may have very different buying frequencies, and they will not not have the same taste, but we can always normalize the items by the purchase frequency across all users. And that is the third one, that is normalize item values across users. And after this, the next step, as we all know, will be split the train and the test set. And we can do it as usual in the 80-20, which is so famous. So 80% of the data will go into training, and to test that, we'll use the 20% of the data. And then I talked about a Theory Create library. So it really helps us to evaluate the models and the performance very easily through this. I will show you how. The other option that you guys have is to write the Python scripts for this. So nobody's stopping you. You can use this, or you can just use a plain Python scripts for this. The next step would be to build popularity model as baseline. And we are going to do this on the purchase count, purchase dummy, and the scaled purchase count. Scaled purchase count is basically a normalized purchase count across the users. Then we'll also look at the collaborative filtering model. Here we will go for the cosine similarity and the Pearson similarity for all these three options. And then as part of the final steps, we will do model evaluation. And like Rajesh already explained, we will use root mean squared errors, recall, and precision. We will build the final output. That data frame will be saved into a CSV file, and then we will see how to upload that to Analytics Vidhya. So with this, I'm going into a video. I hope this is visible. 1 second, I'll just increase the size. And all right. So I'm just going to play this. I hope this is visible. So you can see the first cell. Now this is the Watson Studio. You will get this as part of the registration in the light plan. You will be able to go to the AI services, add a Watson Studio service, and you can start writing your code over here, right? So in that first cell, you can see that I have added a project token. But you do this, this is so that you can easily save and get your file from the cloud object storage, which is your main storage. And I will quickly go through, the steps that I've followed for this sample implementation. And you can see that that library that we're talking about, the Theory Create, we can easily install this using pip install. So you just have to say !mark pip install Theory Create, and then we'll just go step by step. So then the first step, how do we access this? You have to click on these 3 dashes over here and say insert the project token. That's how you will get this first cell. This will help you to access all the files in the cloud object storage. Coming to the next step, pip install Theory Create. I've already explained this. Whenever you want to install any library in Watson Studio, you just have to give that ! mark. In this third cell, we see all the libraries are getting imported, like pandas, sklearn, and Theory Create. After that, this is, I would like to pause here. So this is how we will be importing a file from the cloud object storage. As you can see, there is some credentials required. As soon as you create a service for cloud object storage, you can just go to service credentials and import the file directly over here, right? And then you can see we are going to create a data frame from that file directly. This is automated for you, so you guys don't need to bother about this. All I'm doing is I'm selecting few columns. Like Rajesh said some time before, that we don't need all the columns for the algorithm. So what I have done is I've just selected 2 columns. One is customer ID and the stock ID. The stock ID is your product ID. So you can see we have created a data frame with customer ID and product ID. Now this is your test data set. So this is the customers in the challenge. These are the customers that you want to predict for, and you upload this file into Analytics Vidhya channel. So I have just taken the unique customer IDs from there. And from that, here we see there are 628 customers to be predicted upon. The first file, that's the training data. This is the shape. When we say shape, it just tells you how many rows and columns are there. And so it is customer ID and products. The third step, as I already said, will be data preparation. So like I said, there are 3 things that are very important to us. And to build that, what we will do is we will break down each list of items into product column and the customer IDs. Maybe I'll just pause that and go back and show you this. So you can see that what we've done is from the transaction products, we have to apply this lambda and split the data. All right. And then we get this customer ID and the products. And we are setting an index over here, resetting the index. In this step, what we're doing is we need to get the purchase count. So like I said before, we need some basis for a rating or a ranking. Here we are going to choose the purchase count. So we have the customer ID, the product ID, and how many times this customer has purchased this product. That is your purchase count. And how do we do that? All we needed to do that is we just group by the customer ID and product ID, and then we aggregate it and we take the count, and this is how we're getting the purchase count. So that's how simple it is. So I've just created this video so that we can all follow. So you can see I've just done a heads, and you can see the first two rows over here. The next step is create data with the user, item, and target field. Like I already said, your purchase count, the purchase count will be our target field in the first step. So we have three types of targets coming in. One would be your purchase count, second would be your dummy, whether the item has been purchased by the customer or not, and the third one will be your scaled purchase frequency, that is your normalized purchase, normalized over the purchase count across the users. So let's see, what we're going to do is how we build this up. So we can see that we are melting the transactions, and we're getting over the customer ID, the products, and then we are also adding the purchase count. So you can see the purchase count is getting calculated. So in this step, you can see that we are going for the second type, that is a create dummy. As I already said, if it is purchased, it will be 1, otherwise it will be 0. And the third one is 3.3 section. You can see how we normalize the item values across users. And how do we do that is, see, you can see this cell. Maybe I can. So this is the purchase dummy. So I'll just stop it here. You guys can see the different customer IDs. So 0, 900, 1800, these are the customer IDs, and the product IDs split across the columns. Now what we do is, like for example, customer number 900 has purchased 2 items of this product, that's a stock ID, and 1 item of one quantity of this stock ID. So we're going to split it like that. And then we're going to normalize it such that all the values in these cells are going to be between 0 and 1. So that's how we're going to get the scaled purchase frequency. So like I said sometime back, this is, we are getting it in the normalized form, and this is the formula that we're using. And you can see it's all in the metric. So we're getting the shape of it. It is 972 cross 3810. And here in this output of 71, you can see that all the values are between 0 and 1. So I'm just showing that it was 2 and 1. After normalization goes to 1 and 0. So just to brief here, you might have questions. We had 3 ways to do it. Either we use purchase count, or we use the purchase dummy, and the third is the normalized count. Okay. So maybe so as I said, it's between 0 and 1, and 1 being the most number of purchases for an item, and 0 being that 0 purchase count for that item. And then as usual, we know that the split of train and test items, we use 80-20 ratio, as we all know. And we just have to split it based on this. We will be using the train test split from the sklearn, right? And it's very easy. So we've split the train data and test data. This is for purchase count. And we will be doing similar things for the dummy and the purchase frequency, right? And now we go to the baseline model. So you can see we've done it for data dummy and the data normalization also. Now, when we go into the baseline model, we are going to use a popularity model as a baseline. So like it makes the most popular items for recommendation, like Rajesh had explained some time back. And these are the products with the highest number of cells across the customers. And we will see how Turing Create library will be used for running and evaluating this process. So you can see the three fields, the most important fields will be user ID, item ID, and target. So user ID will always be your customer ID. The item ID will be your product ID, and target will be your purchase count. And then what we do is we write the users to recommend. So you just list down the user IDs from your training sample, and we will proceed. So this is how we're going to apply the popularity model. So we'll say popularity model dot recommend. It's like, you know, when you do, I'm just stopping here, like when we do model.fit, that's exactly what we're doing here using TC. So here we can see how Turing Create is helping us. And you can see that I've just written, I've imported Turing Create as TC and I say TC.popularity recommender, TC.item similarity recommender, and item similarity recommender. You can see the difference will be in the name over here. So you can see cosine, you can see Pearson here. And with this, we will be able to evaluate these models. So again, the model is going to get created this way. So like after purchase count, we will do the same thing for purchase dummy. Basically what we're trying to do is we're going to see which of these methods would give you the best results, right? So any machine learning problem, it's always recommended that you use, you know, even if you're using a minimum regression or a classification technique, you have to make sure that you're using, you know, multiple of them to evaluate and see which one works for you. Right. And so you can see here, you know, when you're seeing the product ID, so at least 2 people have bought this. That is the kind of results that we are seeing. So that is why, based on the popularity, this 850999BJ will be the most recommended. All right. Then we go to the collaborative filtering model. We have already explained that there is cosine similarity and there's Pearson similarity. I will be updating this notebook on the GitHub link, so none of you will have the problem searching. So you have the name, you have the target, as always, it's purchase count over here. And you've mentioned cosine. We will get the ranking here. Similarly, we will do it for purchase dummy and a scale frequency. So you can see the ranking over here. Now, just before I close, you know, whenever you want to save any file onto the cloud object storage, what you have to use is simply with this one line, you will be able to save your file onto the cloud object storage. Okay, now before we proceed, I mean, I just want to show you one output file. Like it could be cosine. So we have 9 combinations, like we can have cosine, Pearson, and popularity, and purchase counts, dummy, and the normalized purchase frequency. So when we do that, we have to find which are the top 10 ranks. So here you can see for customer ID 127269, for the various product IDs, we've got a score. Now the score can be how popular it is, or the cosine, from cosine or Pearson, we get the score of correlation and we find the ranking over here. So this is how we have converted purchase data which had no rating, no ranking, into a data which we can use for further processing. So you can see that we are creating a CSV file from the data frame. And because in Analytics Vidhya, when you people submit, please make sure that it is in alignment with the sample output file format. So you would need it, you need to clean it and make it similar to this. And another way that we can represent it is that we have written a function to create a desired output. And what we've done is for each customer, what are the different products that we recommend. So we've written a function over here. And this will, the output will be for each customer, what is the recommended products. So you can see for customer ID 1890, you can see all the products recommended. So with this, I will end the implementation part just to revise. So we have 3 types of bases. One is a purchase count, one is a dummy, and one is your normalized scale frequency over purchase counts. And we have used popularity, cosine, and Pearson. We have evaluated these models based on these 3 and have come up with the root mean square error. I would like to show you that before I close. So you can see the root mean square here. So you can see in cell number 40 that I'm showing currently, there are different models like we already explained. And with this, we will be evaluating this model. So maybe I'll just play this. You have a utility from Query Create, which will help you to compare all this directly. So you can go and check out this notebook, how we are evaluating all these 3 models, and we come up with the results. So and there's precision and recall also. So obviously, whenever model is going to be evaluated, we're going to see based on, the RMSC. So you can see the popularity on purchase count is 1.11, cosine is 1.9, Pearson is 1.9. So after, if you look at this result quickly, you will realize that popularity on the purchase counts sounds good and it looks good to us. So we will pick up the popularity based on the purchase counts for a final model. And that's how we all should do I'm just suggesting you should go for any machine learning algorithm. So eventually we will use the popularity model and train the recommender system. That is this function. Okay. So let me go here. So once the implementation is done, the next step will be to save your file onto the cloud object storage, right? This is, as you might be knowing, this is your Watson Studio IDE. Maybe I'll just increase this a little. Okay, so you can see that this is how we're going to save a file. I will send you the code for this. And we will see that we have 2 options. One is using the cloud object storage. So if you want to go to cloud object storage, you just go to resource list. In resource list, you can go to storage and you click on this cloud object storage. Once you do that, you will be able to see different buckets. Our recommendation engine output will be part of a bucket that we got. We can see that. And this is your Watson Studio assets. Now, whenever you start with a project, all you need to do is go to the browse, select the input data sets, and upload it into this environment. So this is your IDE kind of a thing. And once you upload it here, it will be all available to you in the notebook. So you can see the bucket name and the file name and the message. Now I'm running it. Once the cell is run, you can see the bucket name, file name, and the message. So I know the bucket name now. I will go to the cloud object storage, click on that bucket name, and go to the file name that I had given. So I know it is recommended purchase. I will go and click on the download. Once I do that, it is getting saved onto my system, to my local file system. You can see it also comes into the assets of the Watson Studio. You can easily download from here as well. And now once it is done, you can just go and open it. Maybe, yeah, I'm opening it. You will just see it. So you can see that customer items, that the products which are recommended is all here. Now the part of the final submission, you have to go to the Analytics Vidhya page. And this is the page, and you have to go to the home. Here we will go to the solution checker. And we will upload the file. It's a CSV. So you can see there are sample submissions. You can download the file from here. You will just open the output file that we received. Give her any description that you would like. And this way you can enter the challenge in Analytics Vidhya. So I would encourage all of you to, go ahead and see. You will also get a submission score. You can close this. To see your name, the leaderboard, you need to click on that and see the results. Right? So it's already 8:56. I'm just going to close this.
Yeah, thanks, Bino.
Yeah, Rajesh.
Yes, there are queries around the availability of the GitHub and
yeah. So this is the GitHub link. And
okay, yeah, please make a note of it. And so the evaluation approach, of course, we use the F1 score and precision and recall, the basic way of doing the precision and recall, and then we give weightage to the like the precision part while computing the F1 score, right? So what is recommended and the precision, and what is recommended being bought by the user is the recall, right? So here, since we are only asking you to recommend, we are giving little weightage to the precision and the computer the F1 score. All right, so that is about one other question. So yeah, if someone is saying I'm able to reach 0.15 with ELS, okay, yeah. I think probably try leaving out some data to improve the precision. You can give it a try. As I mentioned, the correlation, some linearity you will see with a sample of the data. That may not be the good approach, but nothing wrong in giving it a try with that. Right? Try all the crude way. That's the way to deal with the machine learning, right? And of course, getting the high accuracy alone is not sufficient, right? And but in this case, yeah, we have taken care of the recall factor as well in the F1 score, but give it a try. Okay, and someone is saying I'm trying with k-mean clustering approach. Can you please suggest how can we approach once we have purchase count? You have got the purchase count, and all right, now you may have to, I don't know, the purchase count alone may not help. IBSK means definitely will, right? So the next step, obviously in this case, right, that's what we are recommending. Try ranking. Probably you can create your way one approach in terms of ranking, right? And then kind of get into it. Okay, I think you are still the purchase count may not help here. That's what I would say, but I think we can put it in the Slack that is available over there in the contest page. We will discuss it out, right? And okay, yeah, R also is possible. You can use R, all right. And some other queries which I have addressed about the normalization. Okay. Yeah, to create model is performing very bad on the data set. Maybe, right? We have just taken to recreate here to kind of give the put the first gear and move on, right? And right, we'd love to see the other approach, okay, which is kind of kind of giving us the better result. Right. So Okay, thank you. Right, so I think right, so feel free to put your queries in the Slack that is available in the contest page. That is again being monitored, and we will love to answer your queries. And please make use of this GitHub, what is available as a base, and try to improve upon this. And like we will write blogs, and then we will make it available through analytics Vidhya. So in the next blog we will give you the details about how you can export the model and then make it available as an API consumption, which we have not covered today. So look forward to have some blogs from the consumption per se, and we would love to see your active participation in this challenge. Okay, so thank you from my side, and over to you, Arnav.
Thanks, Rajesh, and thanks, Binu, for a wonderful session today. And thanks
Thanks,
everyone for
Pranav.
attending.
Thanks, everyone.
I've just posted the competition page in the chat window again in case anybody missed it earlier. And we did record the webinar, and we'll make it available in the next 2 or 3 days with everyone who attended today. Thanks again for attending.
Yeah, thank you. One last question, quick. Can we do it in Jupyter and upload? Yes, you are free to do it. Okay, feel free to do it in that. Okay, thank you so much. Thank you all. Have a good day.
Thank you. Bye-bye.